Hi, in this video, we are going to talk about new topic. It is one of the types of clustering, but it comes under density-based algorithm. Uh, both the before we seen K-means algorithm and hierarchical clustering. They both comes under distance, but here DBS comes under density-based algorithm. Let's see what is EBS scan and its types and its algorithm, advantage, disadvantage, and equations. Many of well-known clustering algorithms make implicitly or explicitly the assumption that data are generated from a probability distribution of a given type. Example, when a mixture of K Gaussian distribution, this is the case in particular for EM. EM means expectation maximization clustering, and for K means due to this assumption, these algorithms produce spherical clusters and cannot deal well with data sets in which the actual clusters have non-spherical shapes. Non-spherical clusters occur naturally in spatial data, that is, data with a reference to some 2 or 3 dimensional concrete space corresponding to our real world spatial data into points, lines, polygons, and support a broad about a broad range of application. Broad range of application. Clusters in spatial data may have arbitrary shape, that is, they are often drawn out linear, elongated, etc. Because of the constraints imposed by geographic entities such as mountains and rivers. In geomarketing, one may want to find clusters of homes with a given characteristics. Example, high income homes. While in crime analysis, one of the goal is to detect crime hotspots. That is high, that is hotspot. That is clusters of certain types of crimes. Even in higher dimensional data, the assumption of a certain number of clusters of a given shape is very strong and may often be violated. In this case, algorithms such as k-means break up or merge the actual clusters, leading to inaccurate results. The objective to minimize the average square distance of points from the corresponding cluster center leads to a portioning of the data set that is equivalent to Voronoi diagram of the cluster center, irrespective of the shape of the actual clusters. This illustrates this weakness on a small two-dimensional data set showing that K means if the K is equal to 3 breaks up and merge the 3 horizontal clusters. This observation motivates the requirements to discover clusters of the arbitrary shape. The increasingly large size of real-life databases require scalability to large databases, that is, efficiency on databases up to millions of points or more. Finally, finally, the clustering of large databases require the ability to detect and remove noise and outliers. The paradigm of density-based clustering has been proposed to address all of these requirements. Density-based clustering can be considered as a non-parametric method as it makes no assumption about the number of clusters or their distribution. This is a diagram, it's a flat structure of density-based algorithm. Next, density-based clusters are connected dense areas in the data space separated from each other by sparser areas. Furthermore, the density within the areas of noise is assumed to be lower than the density in any of the clusters. Due to their local nature, dense connected areas in the data space can have arbitrary shape. Given an index structure that supports region queries, density-based clusters can be efficiently computed by performing at most one region query per database object. Sparse areas in the data space are treated as noise and are not assigned to any clusters. Next, it is worth nothing that the algorithms that are being referred to it in the literature as density-based clustering have various precedents that have already explored. Some of the ideas, in particular, Michaud explored ways to avoid the so-called chaining effect in single-link clustering, which is caused by small number of noisy data points that connect sets of points that should in principle form separate clusters. First, non-dense points that have fewer than k neighbors within a distance of r are removed. Second, single link is employed to cluster the remaining points. Finally, non-dense points may be allocated to one of the clusters according to some criteria. We would also like to point out the relationship of the paradigms of density-based clustering and mean shift clustering. The mean shift procedure is an iterative procedure. Mean shift procedure is an iterative procedure that replaces each point by the weighted mean of its neighboring points, where the neighborhood and weights are determined by the chosen kernel function, and it converges to the nearest stationary point of the underlying density function. Mean shift clustering employs the mean shift procedure as density estimator. In mean shift clustering, very narrow kernels create singleton clusters very wide. Kernels create only one cluster and the intermediate kernels create a natural number of clusters. As opposed to density-based clustering, in mean-shift clustering, the neighborhood membership is weighted instead of Boolean. The minimum number of points does not need to be specified, and there is no guarantee that clusters are connected. It is, I already told, it is the plotting diagram of database density-based clustering algorithm. For this, this was the preface. This observation motivates the requirements to discover clusters. This was the observation for that, for that picture. The observation was given here. This observation motivates requirements to discover clusters of arbitrary space that increasingly large size. Thank you.